So thank you guys for coming to my session. I know there's a load of different sessions on. There's like 9 different tracks, I believe, and there's some amazing speakers on at the same time. Some of my closest friends, so I really appreciate you guys ditching them and coming to see me. So thank you. Don't let my name trick you. Yes, Dutch surname. I speak absolutely zero Dutch, unfortunately. Completely English born and bred, except my grandfather, who is Dutch, hence the surname. So yeah, kind of a trickster Dutch person here, but I love coming back and visiting. This is my 2nd time at JFall. I was at JSpring earlier this year, so I absolutely love coming back to the agile community. It's a fantastic place to be. And you may have also seen one of my recent articles in the NL magazine that is currently downstairs. I sort of got excited when I saw that. So thanks for joining this session. We're going to be looking at, okay, how do we combat the struggles and the challenges that we're facing now as modern cloud native Java developers. And we're going to look at some of the tools and technologies through things like IDPs, for example, that can help us, hopefully, to tackle some of these challenges. So why do we care about trying to be more productive? Why are we trying to move towards cloud native when we're building Java applications? And I apologize if you've seen this slide before. I just love it too much not to include it. It's this feeling we get as developers. If you've not seen Toy Story, that's your homework for tonight. Go and watch Toy Story, great movie. It's this feeling we get as developers of, ooh, the cloud. We get excited about the possibilities, the innovations, and the behaviors and characteristics that the cloud enables our applications to have. Flexibility, portability, speed, innovation, all of these fantastic qualities, that's what gets us excited as developers to move to the cloud. However, it doesn't always feel like this. Often, it feels more like this. We're annoyed, we're stressed, it works on one machine, and then it doesn't work on the next. It's just a frustrating process, and these frustrations isn't just because of where we're deploying, but also the increasing sort of responsibilities and challenges that we face as the cloud-native ecosystem develops and continues to evolve. So in this presentation, we're going to take a look at how the hell we even got here in the first place. We're going to look at sort of some of the developer struggles that we're facing, and then we're going to take a look at platform engineering, internal developer platforms, and internal developer portals, and why that might be something to consider in terms of helping to tackle some of those struggles. And then we're going to take a look at some of the benefits that offers and the tools that we can make use of. I do have a lot of links throughout these slides. I've got a whole resources section at the end as well. So if you guys do want these slides, I will be posting them afterwards, and I'll also get a way to get it to the conference for anyone who does want them, but they will also be on Speaker Deck. And if you follow me on Twitter, I'll be posting the link there. My handle was at the beginning, but it's also at the end, so don't panic if you missed that. So, what the hell happened? Why are we facing so many struggles and issues now than we were previously, for example, back when we were building perhaps on-prem, more monolithic style applications? And it's partially to do with this. I quite enjoyed this meme. You build it, you run it, not run away, hopefully. It's this sort of shift left mentality that we're adopting, which is increasing our cognitive load as developers. You know, it's not just app development that we have to worry about anymore. We're not just doing devs. We've not just got a dev and an ops team. We've moved on to DevOps, FinOps, MLOps, GitOps, DataOps, DevSecOps, BizDevSecOps. You know, the end, it's almost an endless list of ops. In the words of Chandler from Friends, could there be any more ops? Because there's a huge list here that we're having to gain skills in, gain knowledge in, and be able to implement ourselves as developers, and we're gaining more responsibility. So previously, in more traditional app development, we may have had a split that looked a bit more like this. So you can see the lighter blue is our dev responsibilities, and the darker blue is our ops team. Happy devs, not so happy ops, especially when we had this mentality of sort of chuck it over the fence and they'll deal with it. So we've been moving gradually towards more of this style of sort of app delivery. And what that means is that we've taken on more cognitive load as developers when it comes to the various different aspects of actually delivering an application. And not only that, but we're now expected to not only take on more of these, but we've also added, we now have to make it more usable, more observable, more flexible. We have to have code quality in there. So it's this growing list of responsibilities that devs now have to take on, And on top of that, ops now have to deal with technologies that they may not have had sort of access to or be familiar with from before. So they've got a challenge of moving to sort of Kubernetes and upskilling on this area, and we've got the challenge of taking on more of these responsibilities ourselves. I quite liked this, this sort of quote that came from Humanitec's Luca Galantine. The movement to shift left has forced developers to have an end-to-end understanding of an ever-increasing amount of complex tools and workflows. Oftentimes, these tools are infrastructure-centric, meaning that developers have to be concerned with the platform and tooling their workloads run on. So, as Luca sort of says, it's not just the tasks themselves, it's all the tools and the platforms that we have to understand as well to be able to do those tasks in the first place. Speaking of tools, this is another huge issue we face. As well as this shift left, there are so many tools out there, it's difficult for us to be able to pick which ones to actually use in our applications, which ones are going to be best for our specific use case. You know, all you need to do is take a look at what I like to call the cloud-native grocery store to pick out which ones you want to use. I have a challenge here for you, just to illustrate how confusing this is. I've put Wally in there. Can anyone spot Wally? I'm going to give you a few more seconds just to see if you can spot him. I have made him slightly bigger than the others, so he should be a little bit more obvious. Yeah, a few of you. There he is. But the whole point was that was hard, right? It took you a few minutes, even with a huge screen like this. It's a confusing map. There's so much choice. It can be very difficult to know not just where to start, but which tools to pick and choose. And this sort of leads me on to my developer struggles. So with this move to shift left and this increase in cognitive load, this increasing number of tooling and available frameworks, we have various different struggles that we're facing. One of which is sort of our CI/CD tooling. This is quite a steep learning curve, especially if we haven't done cloud-native development before, or even if we're a brand new developer. Sort of, as Sharat was saying, that next generation of developers coming up, not only have they got to learn Java and all the original frameworks that our applications were using, they've now got to learn this whole new ecosystem as well. As I said before, there's also a lot of options. Choosing which ones to use is challenging. I enjoyed this meme. I've got the source down here. You sort of start off learning containers, and you're like, yeah, I'm getting there, almost there. And then you start discovering Docker, and you're like, cool, this is interesting, getting onto more complex stuff. You start to understand Kubernetes, and then suddenly you realize that there's a whole lot more to cloud native than just containers, Docker, and Kubernetes. So it really is sort of challenging when it comes to understanding which open source standards to use, understanding how to enable effective observability in our CI/CD pipelines, and which tools to make use of there as well. Another challenge, container management. One doesn't simply run a container. There's a lot of different steps and processes and tools involved when it comes to actually enabling effective container management. Not just about ownership, but we're also looking at cost management as well. We're now working more as sort of a DevOps team rather than just throwing it over to ops and hoping they deal with it. The nice thing about containers is that they do provide us with that portability and flexibility, but there's lots of different decisions involved in enabling an effective container management. So which tools are you going to use? How do you configure your environments effectively, both for sort of performance, but also for cost? How do you build your apps within those containers? And it's challenging to ensure that in this world of lots of different tools and possibilities, how do you ensure consistency and that you're sticking to best practices as you're sort of enabling container management in your various different silos and teams? Because one team might be doing it completely differently to another team, depending on your application and your organization. Now, there are things that can help with this. So, for example, operators and cloud-native build packs can help by providing that sort of central location through which to sort of grab images and sort of dependencies and stuff, and having that sort of single operator that you can easily deploy to different clouds. However, they don't solve all of these issues. Another one is security and regulatory requirements. This kind of comes back to that consistency element that I pointed out earlier. As you can see, big Disney fan, so I have a lot of Disney memes in here that you'll see coming up. So, you know, being aware not only of the tools, not only of the technologies and the architecture and the code, but also the regulations that we have to be adhering to depending on where we deploy our application. What kind of data are we dealing with? Do we have to be worrying about things like privacy of our data? And also things like what's in our application. Are we aware of the security vulnerabilities we could be facing? Especially when we're making use of open source tools and technologies, it's vital that we know what's in our application so that we can be aware of potential vulnerabilities and security risks that we might be facing. So having things like SBOMs, so security bill of materials, being aware of vulnerability, whether that be in our source code or in the images we're using or external libraries we might be dependent on. Having that sort of trusted software supply chain. So do you know where your images are coming from, and do you trust that source? Maybe there might be compromised credentials in our code. Now we have to worry about that and ensure that we don't have anything within our code that could potentially create a security risk. And there's also the issue of authentication and authorization. So trying to enable sort of not a everyone can access everything approach, ensuring that we have the right access for the right people to the various aspects of our application to ensure that we're as secure as possible. Other struggles, because that wasn't enough. More struggles that we have include the fact that we're probably drowning in scripts, and subsequently maintenance costs. You might say today that you'll just hire more DevOps, but this doesn't really scale when you start actually trying to scale that up. We often, no matter how hard we try, we often can't reach the degree of automation that we want because we don't have the necessary scale. Often, we have key person dependencies. Any maintenance update depends on someone who knows exactly what config to change and where. And this works great for the first year, but the average time in a job in our industry is just 1.4 years. So if people are changing that regularly, often we're spending time skilling people up and they're not actually available to be able to work on some of these things. We lose that skill set, and we still have a key person dependency that we're waiting on to be able to get an environment up and running, for example. Every time a dev needs a new environment, they have to interrupt a colleague in ops and wait for its creation is often a key sort of characteristic. This fact that creating a new environment is a very long process, and environments can get blocked in testing. So all of these struggles lead to a feeling like this. No, I don't want to do it anymore. This sucks. And this isn't just a feeling that, I'm feeling. There are many different surveys and sort of like questionnaires and things like that and studies out there that show that developers really are feeling the impact of this cognitive load. They're feeling burnt out. They're feeling like it's an awfully big amount of work for just a smaller team. In fact, this was a survey done by Salesforce in April 2022, so quite recently. And this reveals some of the key challenges that organizations are facing. So the fact that the developers are feeling burnt out because of increasing workload, as I was saying, all those responsibilities, pressure of that digital transformation, and requirement to learn new skills. It can be extremely challenging. In fact, 76% of organizations say cognitive load is so high, it causes angst and low productivity, which is just a negative repeating cycle. If we've got low productivity, they're going to be more stressed because they're not able to get that work done. There was a really nice tweet here from Luca, who did a survey. I quite enjoyed some of his potential answers. Do devs really want to be involved in ops? Do we want to have this responsibility? And actually, a lot of the time, it's a no, because they have all of this other workload to be dealing with. So with all of these struggles in mind, how can things like platform engineering help us to be able to hopefully take away some of this cognitive load and enable us to be more productive and more efficient as developers in this modern cloud-native world? So the fact is that most developers require the same sorts of technologies, which often can be standardized across an organization, or at least across a development team. For instance, let's take the consolidation around containers and Kubernetes, infrastructure as code, and the need to implement similar build configurations and security policies across applications, because you're most likely going to have the same regulations and requirements across your organization that you can then standardize in regards to sort of security that way. So what we can do is we can enable platform engineering to be able to sort of centralize many of these standardizations and sort of enforce government and build out internal standards. It's actually sort of growing in terms of popularity. It's just sort of emerged onto the Gartner hype cycle as an emerging technology, and it's growing in terms of the number of companies investing in it and utilizing that within their application development. But what is platform engineering? So this is from platformengineering.org, and I've highlighted what I think are some of the key elements in this definition. Platform engineering is the discipline of designing and building tool chains and workflows, another word for workflow being a golden path or a paved path, that enable self-service capabilities for software engineers in the cloud-native era. Platform engineers provide an integrated product, most often referred to as an internal developer platform, covering the operational necessities of the entire life cycle of an application. So essentially, the key parts here is it enables us to have these workflows, these paved or golden paths, that we can utilize in a self-service capacity, so we're not being limited by having that key person dependency here, and it's all sort of enabled through this internal developer platform. So really, this platform engineering is all about having, as Sharat was saying, it's about putting developers first. It's about having developer-first infrastructure and improving the developer experience when it comes to enabling and developing cloud-native applications. So a lot of people look at this definition and look at the hype around platform engineering, and they say, platform engineering is the future. DevOps is dead. I say no, because we have this sort of chain here where we say DevOps is dev, platform engineering is the future. We just need to utilize DevOps practices and tools to actually build the platform, and we're like, that might be a problem. If we just get rid of all DevOps, we're never going to be able to effectively build platform engineering. So actually what I would say is DevOps isn't dead. Platform engineering is just an iteration or an evolution of what we might have considered originally DevOps, because it still involves many of the practices and the sort of skills that we require within DevOps teams and DevOps practices, just in this concept of platform engineering. So this is also supported by experts in the field like Bryant, talking about the fact that DevOps has caused friction and solved many challenges in the software development lifecycle, but much of platform engineering is positively grounded in the ways of DevOps. So concentrating on flow and systems thinking, even shorter feedback loops and continuous experimentation. So these sort of core principles in DevOps still apply in platform engineering. When it comes to platform engineering, in terms of implementing it, it's kind of a very abstract concept because it covers a wide range of our application development lifecycle, because that's the whole point. It's meant to be supporting the whole lifecycle. So there are 6 foundational pillars that comprise the majority of platforms for platform engineering. So it ranges from security through to pipelines, provisioning, connectivity, orchestration, and observability. Now, again, you'll be looking at these key elements and thinking, actually, I do a lot of that in my DevOps practices. So this is what I mean and what I'm referring to in terms of a lot of the same principles and key skills can be utilized in platform engineering as well. The reason they're in this order is really kind of, it's supposed to be maybe what you think about first in regards to platform engineering. So starting off with security, so you have that all the way through, looking at your pipelines, once you've got something deployed, how do you provision it, connectivity, etc., and then orchestration and observability. When it comes to how to do platform engineering, it's really all about creating yourselves a recipe so that you can essentially bake your own platform cake, as I like to call it. So there are various different elements that relate to these key foundational pillars that you have to consider if you want to effectively enable platform engineering. So this is essentially the recipe that you need to be following, and you need to choose your ingredients from this recipe. We need to decide on an IDE of some kind, whether you're using Visual Studio Code, IntelliJ, Eclipse, whatever it might be, standardizing that as your first step. Looking at things like version control systems, are you using GitHub, GitLab? What are you using for that? And standardizing it again. So going through each of this list and determining which tools best suit your organization so that you can create the standard set of ingredients that all of your organization then can use within platform engineering. It also includes sort of going further down the list. We start to get more into DevOps style rather than just pure dev, so like IDEs and stuff. Looking at things like CI tools, so whether you're using Circle CI, GitHub Actions, Bitbucket, GitOps tools like Argo CD can be really helpful in this process if you're not already using them. Infrastructure as code can be a really helpful tool in regards to platform engineering, allowing us to be able to standardize and have sort of a coded way of enabling the infrastructure that our application depends upon. So tools like Terraform, Ansible, Pulumi, Crossplane, these are all really useful tools that can help with this. The reason I haven't put the list up here is because we'd have a Where's Wally situation again. There's a lot of choice, and so this is where it's really down to sort of selecting those standards and ensuring that you stick with them throughout your organization. So it was kind of mentioned in the keynotes this morning about having that higher level of, right, what are we going to use across the board, this art form of selecting the tools that best suit us, and then standardizing that. And what this allows us to do is kind of like this. So we go through this DevOps cycle, and we look at each element within it, and we pick out the tools that are best suited to our organization that we'll then use as the standards for platform engineering as we go ahead. And then what this looks like once we've chosen these tools is a bit like this. So what we normally have is a platform engineering team, and they are the ones who are going to enable platform engineering for our organization. So what it's doing is taking some of the responsibilities that we had previously inherited as developers, and that ops had kind of given over in a sense to us, and instead giving them to a new team that just focuses on standardizing them, and that's the platform engineering team. So the platform engineering team is going to take the choices. Now, they may make the choices, or it might be senior devs or senior members, technical members of your organization who make the selection of choices for those ingredients. But either way, they're going to take those choices and they're going to enable an internal developer platform that can be accessed through an internal developer portal for developers. And this is where we get into the specifics of how we enable platform engineering in organizations to tackle some of these challenges. So the first step is that internal developer platform, IDP. Now, with the tech industry, we love an acronym. The confusing part is when we use the same acronym for different things. So you might see online people refer to the internal developer portal as the IDP. In this case, I'm saying it's the internal developer platform is the IDP, just so we're clear on that one. So what is an IDP, and in this case, a platform? So this is the definition I have here. This is a really useful diagram that I found from Configure8, which is a proprietary organization. They have a proprietary product that you can make use of for IDPs. But in this diagram, I've kind of circled which part is the IDP. You can see it in the center here, connecting off to several different sort of plugins and backends for the different choice of that tooling that I mentioned earlier. So an internal developer platform, really what we're referring to here is a collection of tooling built by platform engineers and used by developers. It's often a heterogeneous tool chain that's stitched together in a way to minimize cognitive load for developers, without abstracting away important meaning. So it's all about having this central collection of tools, services, and workflows, providing us with that service layer to be able to actually make use of that as developers. Now, the key parts here is sort of why it was called this internal developer platform is really to emphasize who this is for. This is for internal use, so this is really to separate it out from anything you might be producing externally or for externally facing customers like Twilio's developer platform, for example. It is separate to that. This is just for your internal company. Developer, this is all about putting developers first. It should be the developers who are essentially your end user clients. And so you should be meeting their needs more than anyone else's, because it really is a developer-focused platform. They are the primary user. And then platform, so really characterizing the product type that we're making here. So it's not necessarily about, platform engineering isn't necessarily about delivering products to development teams that allows them to focus. It's kind of about allowing them to focus just on their development rather than having to worry about all of the other choices and issues and challenges that we previously faced. Normally they are custom built by a platform team by combining different tools and technologies, whether that be proprietary or open source. It's really up to you as to which ones you choose. And the idea here is to increase developer productivity and happiness at the end of the day. Because if developers are happy and enjoying what they do, they're probably going to be more productive and enable you to have better features and a better application. How are they used by developers? So really the idea here is that the IDPs integrate into any existing workflows that you already have in place. So it usually means that you remain with a git push deploy workflow. You just have that further automation. So the entire deployment process is now at the disposal of the developer. They can request resources, spin up fully provisioned environments, roll back, deploy, and set deployment automation ruling all autonomously. So it's enabling that efficiency through this. Normally what we have is sort of 3 panes of glass, as we call it. So we've got the IDE to code in, Git to merge, and then the IDP to actually help ship it. So we should be able to just interact with those 3 to get through the whole cycle that we need to as developers. That's the IDP, so that's that collection of tools. Now I'm going to talk about the portal, which is different, so it's important to separate these 2 concepts out. So the portal is this front-facing aspect in this diagram here, so it is a separate component to the IDP itself. This is really the interface or the face through which we can interact with the IDP, and it allows us to be able to use it to access and discover all of the capabilities that our IDP enables. So it allows us to have that sort of self-service element to it and an easy single UI to be able to access all of those capabilities within it. And there are lots of tools that can enable us to create this single UI, this portal. There's a lot more tools available that I'm going to talk about to enable the portal because it is a tangible physical UI or tangible physical, sometimes it can be a service catalog, for example, but it's a tangible thing that we can make and interact with. The IDP, on the other hand, there isn't really a single tool that I can recommend for that. I will recommend a couple of things, but because that's more around a collection of tools and services, it's more around a methodology of how you enable that within your organization through that selection of tools. So there's lots of tools that can be used for that. So just to separate between the 2. So the important part here is internal developer platform does not equal an internal developer portal, but the 2 can be used together to enable efficient platform engineering within your organization. Okay, so now that we got that clarity and we understand a bit more about these key definitions, what benefits does this give to us as developers specifically? So as I mentioned, we're sort of moving some of those responsibilities away from the developer. So now hopefully what the developer can focus on is the application itself. Now, that may include things like code quality, observability, like we were talking about before, but it's all within the scope of the application itself. And they can make use of what the platform engineering team are now responsible for, which is sort of that how you build your app, how you deploy it, billing, so cost of enabling that within the cloud, your runtime, your Java, your OS, all those kind of things are sort of enabled in this self-service hub that we provide as standards. And then the ops team, again, have clear ideas of what are their responsibilities in terms of virtualization, hardware, for example, and so they're also clear and familiar with what they're doing within the organization. So it's a lot clearer in terms of who has responsibility and a lot more balanced in regards to it's not all on one or all on another, and you can sort of specialize in what you're responsible for. A lot of the benefits of platform engineering are qualitative. Now, that's not to say there aren't quantitative benefits, but often they come from these qualitative benefits. So how does platform engineering benefit development teams? Well, first thing is it offers this standardization and security in regards to the delivery processes. So it offers us this golden path or this paved path. So we know that when we're developing applications, we don't have to worry about, okay, but I want to use this open source tool, and I don't know whether the licensing is correct for my organization, whether I can make use of it, or I don't know whether it's been tested in the right way, to the right standards that we need. It allows us to be sort of secure in regards to, as a developer, I can deploy and experiment and try things out in my application safely and securely without vulnerability to potential attack, for example. So it allows us to be able to be sort of safe and secure and enable that standardization across our organization. It also enables us to be self-sustainable and self-responsible, so we now no longer have to wait for our ops teams to be able to get an environment up and running or to be able to change some configuration for something we've already deployed. We can now be self-responsible and actually, again, go and experiment, try things out, try new technologies, innovate within our applications, but in a way that's productive and isn't reliant on someone else's time in what is already a very busy work schedule for many people. And also this reduced cognitive load is a big one for us. So being able to, again, refocus on the application itself, innovating within that space, which is really where most of the value within our companies come from, is that application itself and what we're actually offering. In terms of quantitative benefits, there have been several studies into this. This one is by Humanitech. They studied teams that have built an IDP internally. So it included GitHub, Zalando, Sport1, as well as teams that had built their IDP with Humanitech, because they are a proprietary service that offers this. And the data evaluated was surveyed in the team 6 months before using it and after using the IDP. And as you can see, there's a huge sort of benefit to be gained in regards to many of the key aspects of developer sort of development in terms of general creating applications. So waiting time due to blocked environments decreased by 90%. The average deployment frequency, so being able to actually deploy frequently, increased by an average of 4 times. Visibility and transparency also increased. There was an ability to be able to decrease transactional communication. And onboarding, again, talking about the new developers coming into our organization, this enables them to be able to get started much, much faster because they don't have to skill up and understand every single aspect of that SLDC. And our lead time also decreased. So some real, like, actual data that you can take back to your organizations and say, look, we could benefit in these ways, saving money, being more productive, enabling more innovation, encouraging that next generation through actual measurable impact. It's not just developers who are also positively benefit from this, it's also organizations as well. So we've got some facts here for the developers. Again, this comes from Humanitech as well. But for platform engineers as well, they can have a 95% reduction in configuration files by having this standardization and less maintenance overheads because you're not having to maintain a bunch of different scripts and loads of different repositories. And again, having this standardization, this single source of truth, this golden path enables these key benefits for them as well. And in terms of the organization, 30% faster time to market and an 80% lower TCO for your internal developer platform. This is, and there's another one that's Forrester actually did an internal study that was quite interesting to have a read. 74% of DevOps leaders say that improving DevX with an IDP boosted their developer productivity. 77% said that it can shorten time to market, and 85% said that it drove revenue growth. So like key performance benefits that not only developers care about or platform engineers, but your organization as a whole really is working to improve it and would care about. Now, that's not to say there aren't challenges. I don't want this to be a presentation where you're like, platform engineering is amazing, like there's nothing wrong with it. There's obviously challenges, and there is good with bad, as there always is. So just to make sure that you're aware of everything before jumping 2 feet straight into retransforming your whole organization to do platform engineering, there are challenges in terms of sort of enabling precise user authentication. There's also challenges around the strain to platform engineering teams. Many larger companies have faced sort of challenges supporting a large organization with what can be a small platform engineering team. So it is important if you're working in a large organization to consider just how much resource you'd need to have that platform engineering team to create that IDP and to maintain it. Platform engineers themselves might find it hard to regulate standardization of configuration tools and everything else. And they have the challenge of ensuring that the user configuration is precise for user authentication and authorization to access the IDP itself. So there are obviously challenges, and they are something to be aware of as you're maybe considering platform engineering and the creation of an IDP in your organization. However, saying that, there are tools to help. As I mentioned, there is no single open source tool that will give you an entire internal developer platform. You can, if you wish, aim to create your own by combining multiple different tools, like I mentioned. So there's things like Argo CD, Crossplane, all of the different ingredients that I was mentioning to bake that cake. It's that combination that can enable you to create your own IDP. But there are sort of tools that can help us and architectures and templates because we aren't the first ones to go through this. So you can learn from that experience and those companies to be able to base your own IDP on or your own choices. So some of these useful tools. There are some reference architectures that you can go and check out. So this is actually from McKinsey & Co. The one at the bottom here spoke at PlatformCon in 2023, so just this year, about their research looking at hundreds of real-life platform setups. And they uncovered these common patterns in IDP architectures. Now, they're divided up into subgroups. So we've got the developer control plane, integration and delivery, monitoring and logging, security plane, and resource plane. So it's kind of linking back to some of those foundations of platform engineering, those pillars that I was talking about. So this can be really useful to have a look at and is already in use by many organizations today. This is based on real usage. The other option is there is actually some distilled these patterns into different options as well. So the one at the top is from Humanitech. They've got reference architectures for AWS, Google Cloud, and Azure. So if you're already using one of those cloud providers, you can check out their reference implementations. It's available as a PDF free online. And you can go and check out what they'd recommend for each of these same subgroups again. I have put the links up here, but you should be able to just Google, and it should be one of the first hits that you come to. Another one that's really useful is the IDP tooling landscape that's available from platformengineering.org. This is a really useful site, so if you've not seen it before, check out platformengineering.org. They expanded McKinsey's original IDP reference architecture with this tooling landscape. So a bit like the Cloud Native Foundation landscape that we saw earlier, but this one's more specific to IDPs. This allows you to really start from a blueprint. So instead of having that roadblock of, oh, I don't know where to start, hopefully these architectures and reference implementations will help you to have at least a reference to see where you could start and whether that's right for you. Other tools that you can make use of are things like Backstage. Backstage is being talked about more and more. The hype is getting sort of greater in this space. It is an open source project that was donated by Spotify. It is at the moment in the CNCF, and it's an incubating project. This is really all about having an open platform for building developer portals. So it's more focused on sort of the portal element of this. And it's powered by a central software catalog, but you can customize it with plugins to various different other software and tools that you can make use of. And that plugin ecosystem is expanding rapidly. The three things that you get out of the box with Backstage is the Backstage software catalog. So this is for managing all your software, so microservices, libraries, data pipelines, websites, ML models. You get the software templates. So they're for quickly spinning up new projects and standardizing your toolkit or your tooling. And then you get the tech docs as well. So making it really easy to maintain, find, and create and use technical documentation. Kind of like a docs-like code approach is what this offers. So this is a really fantastic tool to check out. There are many different open source projects that build on top of this. One of which is Janus, I think, or Janus, or goodness knows how you pronounce it. There's like a million different ways. I see some red hats in the room, so they'll probably be familiar with this project. It's a Red Hat sponsored community for building those developer portals, and it extends Backstage.io. What it offers on top of that is it's enhanced the Golden Path templates, and it enables sort of additional plugins on top. It helps to provide a highly configurable and secure development portal to control which components can be built together. This is the downstream open source version of this, which is currently in preview. This is the Red Hat Developer Hub. At the moment, currently this is only available to a set of customers as a preview, but if you are interested, Janus is essentially the downstream component of that. So you can check out Janus or Backstage, which is the downstream component of that, to check out what it's kind of going to be like if you are already using things like OpenShift or any of other or sort of Red Hat's products. So this is really aiming at the enterprises, providing that enterprise-grade developer platform for building developer portals. It contains a supported and opinionated framework built on Janus and extends that functionality again through additional plugins to some of the specific Red Hat technologies. If you are interested, there was a really good YouTube video that is up that takes you through sort of a preview of what this is going to look like if you're interested in that. Moving back into sort of the open source world, we've got Kratix as well. So this is an open source project that's been contributed by Centasso, and it enables you, again, to be able to build these internal platforms, specifically on Kubernetes. It enables sort of co-collaboration or co-creation of capabilities by this concept of promises. So a promise are things like developer portals or database as a service, Kubernetes namespaces, or any kind of abstraction that increases developer productivity, efficiency, and security. So the promise, in this case, is their building blocks of that internal developer portal or platform. And this is really about creating a flexible platform with different paved paths by using this premise of promises, where you have this sort of collaboration between development and the platform engineering team to determine what they actually need, what should be in that paved path, coming together to make that promise and enabling those promises on the platform as building blocks that they can use. So this is a really interesting, another interesting open source project. And if you're interested, Whitney, who is a fantastic developer advocate, has made an enlightening video. If you've not seen her enlightening videos before, go and check them out. This one is with one of the developer advocates at Kratix. It's essentially like a light board where she goes through what Kratix is and how to use it. Other options you can use, I mentioned, there's lots of different tools available. These are some of the sort of more proprietary products that you might want to check out if you're interested in more enterprise grade rather than necessarily open source. So things like Configure8, Port, Compass, Cortex, AutoCloud, these all offer similar things to what we were talking about with Backstage and Janus and Kratix. They offer the ability to have sort of this single source to be able to access your IDP, to create this portal, to be able to get analytics and data from it, and to be able to plug into different tools and elements through those plugins as well. Many of these actually now have Backstage plugins, so you can kind of use Backstage with them as well. So just something to bear in mind if you were looking at something more enterprise. Now, the key thing to bear in mind here is that I've talked about lots of different tools. Some of them are sort of more platform as a service, so you're kind of buying into the whole thing all at once through enterprise-grade offerings from companies like the ones I showed in the previous slide. Others are more open source, build-it-yourself type options. There is a wide array of different ways to implement IDPs within your organization, and depending on your organization will depend on where you fall on this scale. It's important to bear in mind that just because a lot of people are building platforms doesn't mean that it's an easy process. The aim is to reduce complexity and give developers this self-service, but you do need to understand that it is a lot of work to create an IDP and to maintain it. So you may want to go more towards the end of sort of buying more of the enterprise ready-to-go style rather than going straight for creating it from scratch, depending on how large your organization is. So it is something to bear in mind as to which tools suit you. That was a bit of a mouthful. Which tools suit you will depend on your teams, your structure, your application, and your organization. The other thing to bear in mind is when you're building these platforms, you are not building them for the entirety of your organization. You cannot and will never suit every single developer's needs. That's not what an IDP is about. An IDP is about helping the 99% developer. The developer who doesn't necessarily need that really odd tool that he only needs for this really one specific piece of innovation. It's about providing 99% of developers the tools and standards that they need that can be shared across the organization. So don't feel like, this is a huge task because you have to fit every single need in your organization. Start with the ones that are shared by most of the organizations and work out. Depending on where you stop, again, will depend on how big your platform engineering team is, how much resource you have to put into this, and where you are as an organization. So just something else to bear in mind. So where are we going in the future in regards to this technology and sort of these methodologies? The future really looks at these two questions of how should you be building the IDP yourself, and how much of that should you be building? And the second one is, how should you be assembling this control plane to be able to give access to this IDP? And this is where companies are really looking at this question and trying to identify how they can help in this regard. So where I see the future of this is sort of looking more at ready-to-go golden paths, so the potential to have recommendations that you can just buy into straight away, whether you're using sort of an opinionated stack, for example. Especially for smaller companies, it can be really challenging to provide enough resource or enough people to make a whole dedicated platform engineering team. So I see in the future, I expect more companies to sort of look at these paved paths or golden paths and how they can provide that as a ready-to-go solution. Another thing that I look at in the future is persona expansion. I focused a lot on developers. Obviously, we are developers in this room, so it's a good audience to focus on. But I expect this persona to be expanded in regards to how we enable more within our organization to benefit from the IDP. The IDPs provide us with a fantastic source of information and data when it comes to how our engineers are developing the platform, and also how our platform is sort of performing itself. So I expect this to be expanded to how things like enterprise architects, QA engineers, data engineers, and even further afield to sort of, I guess, less related, you could call it, like security, finance, HR, how they can benefit from all of the data and the analytics and the insights that we can gain from this central platform and these standardizations. So I expect to see more persona expansion that way. As well as that, I've talked a lot about people. It was mentioned in the keynotes, people are the key source of where most of our innovation and our sort of companies' selling points come from, because the people are what enable our applications and our innovation. But there's also sort of a growing interest in machines, in machine learning, AI, for example, and I see in the future, I expect to see more interest in how can we interoperate more with machine learning models and AI to, again, gain further insights into how our applications are being developed. Can we make that more effective, more efficient, and these analytics and data that we can gain from the IDPs. So sort of more programmatic as well. Sort of another persona of sorts, but not necessarily a person. Okay, so hopefully through that whistle-stop tour of developer struggles, platform engineering, IDPs, and the tools that are available, hopefully what I've shown you throughout this presentation is that cognitive load and demands on developers are ever increasing as we move towards modern cloud-native development. But developers can be helped and supported through things like platform engineering, IDPs, internal developer portals, and those golden or paved paths. What this looks like will be very specific to your organization. So, I've mentioned some paved paths. I've shown some landscapes and some architectures. That doesn't mean that you have to necessarily use those. It's just a good starting point as a reference to start from. But use the tools and technologies that are out there. Check out the examples. There's now a growing number of examples that are available online to look at of organizations of varying sizes. So if you have an organization that's extremely large, check out those examples. But there's also smaller organizations that are more local. So check out those as well. I have a list of them here. So for example, we got some smaller ones down the bottom, like Veterans United Home Loans. And then we've got sort of your slightly larger, like Twilio and Sneak. And then we get up into your really big, Netflix, Spotify's. So these are some really interesting examples to check out how they've enabled IDPs and the benefits that they've gained from this. If you are interested in learning more, this community is growing. So there is the platform engineering guide that's been produced by the folks over at InfoQ. And that's a PDF that you can download for free that gives you sort of a huge array of background and information on this field. PlatformCon, I've mentioned a few times, and a couple of the links in my presentation have been on that. And their recordings are available online. They actually have sessions that are like 15 minutes, so super easy to watch and to get key insights on some of these topics. There's also a Slack channel and a weekly newsletter. And just in case I hadn't given you enough homework, there's more. So here are some additional links, just in case you are a super keen bean and you really want to find out more about this. I've tried to put some descriptions here, so it should be fairly straightforward as to kind of what they're about if you are interested in that particular element of it. So with that, I'm going to say thank you so much for your attention. Please do remember to rate all the sessions in the J4 app. And if you have any questions, I'm available after the session today, or you can catch me on socials. I'm going to say Twitter, but X, whatever you want to call it, LinkedIn, or I've got some blog posts on IBM Developer as well that you can check out on some of these subjects. Thanks so much, guys.